So let's get started. Here we have a 1 meter diameter, that's 1 unit, circle cut out of European birchwood. This circle was cut on a CNC machine. That's a numerically controlled, computer-driven, laser-driven routing machine. It's made in Austria, costs about $100,000. Different vendors use it to cut plexiglass or routing for woodworking, etc. What we're going to do is measure the diameter, show you the diameter is 1 meter all the way around the circle, and then we're going to measure the circumference, which will be pi. As you remember from the basic formula, circumference equals diameter times pi, when diameter is 1, and 1 times pi is pi, and whatever the reading is for the circumference should be pi. Using our 4 meter calibrated in millimeters engineering tape measure, it's a metal blade, we can measure the diameter of this circle. Straight through the middle, we position it at 500 millimeters, and if we pan over slowly to the left edge of this diameter, we will see that it's on 0. Okay, and pan over to the right, we can see that the right side is at 100 or 1,000 millimeters. Okay, so that's one diameter. The next thing that we should do for you is to measure all the diameters of this circle. We will use a beam compass to do this, setting up a radius and then spinning the wheel slowly so that you can see that this circle is indeed 1 unit all the way around the circumference. So now what we want to do is use a beam compass to measure the radius, and as we turn the circle, note that the radius stays the same all the way around the circle, which proves that the diameter is the same. One point is at 0 on the tape measure of the beam compass. The pencils there are there to hold it standing up. And the middle is set at the center of the circle, and it's 500 millimeters. I will zoom in a second. And now we want to measure the pi circumference of the circle. So we use our beam compass and simply roll the wheel around the circle. Notice that the point remains on the circumference, showing that the diameter is constant all the way around. Let's make sure we get this right in the center, and there's the 0 line. We can go all the way around again. And the beam compass shows that we indeed, each quarter of a turn, radius stays constant. It's 500 millimeters, and therefore the diameter is a meter, and here we are back to 0. And now what we want to do is to show the calibration of our 4 meter engineering tape measure to show that all of the meters are equally calibrated on the tape measure. So let's start at 0 and put one edge on the 0 on the circumference of the circle, go across the diameter, and look at the 1 meter mark. We can see that it is 1 meter, 1,000 millimeters. The second measurement we're going to take is from the 1 meter or 1,000 millimeter mark to 2,000 millimeter mark, to show you that is the same on the same diameter of this circle. Okay, if my assistant will move closer to the 2,000. Yes, very good. And you can see it's right on the circumference, perfect. And now let's measure the third meter in the section on the engineering tape. We are at the 2 meter mark, or 2,000 millimeters, and let's pan over here and look at the 3,000 millimeters or 3 meter mark. And as we can see, it's right on the edge, perfect, very good. Now, remember that what we're going to do is wrap the entire tape measure with the calibrated side facing the circumference of the circle, because the tape itself has a width, maybe 1/10 of a millimeter, and you don't want to wrap the tape measure all the way around with the numbers facing outward, or you're a little bit bigger than you should be. So we will wrap the tape measure for the pi circumference all the way around the circle and read what the true value of pi is.